Oh, hello. Assalamualaikum. My name is Muhammad Fadil. My metric number is 23DM21F1001. Today, I would like to present DC converter, which is single phase full bridge rectifier and single phase to single phase cycle converter. Okay, let's get started. For introduction, the single phase full bridge rectifier is a specific circuit configuration used to achieve rectification. It consists of 4 diodes arranged in a bridge configuration. The AC input voltage is connected to the bridge rectifier and the diode act as switches to control the current flow. Next, I will present the circuit diagram of a single phase full bridge rectifier. As you can see, the diagram shows there is a transformer's load and 4 diode, which means the current flow from the AC source through diode D1 and reach the load or the connected device. Simultaneously, diode D3 and D4 remain reverse bias and do not conduct. Next, I will talk about the operation of a single phase full bridge rectifier. Involve the conversion of alternating current AC into pulsating direct current output. Let's go through the operation step by step. First, we have AC input. The AC input voltage is provided to the circuit. It can come from a power outlet or another AC source. Second, diode conduction. During the positive half cycle of the AC input voltage, the voltage at point A junction of diode D1 and D2 become positive with respect to point B, junction of the other two diodes. This forward bias diode D1 and D2, allowing current to flow through them. Third is current path. The current flow from the AC source through diode 1 and reaches the load of the connected device. Number 4 is polarity reversal. During the negative half cycle of the AC input voltage, the voltage at point B becomes positive with respect to point A. This forward bias diode D3 and D4, allowing current to flow in the same direction as before. Number 5 is ribbon current path. The current now flow from the AC source through diode D4 and reach the load at the same time. Diode D1 and D2 become reverse bias and block the current flow. Number 6 is pulsating DC output. The combined effect of the diode conduction during alternate half cycle of the AC input result in a pulsating DC output waveform. The output voltage is positive during the diode D1 and D2 conduct and 0 during the period when diode D3 and D4 conduct. Number 7 is ripple content. The pulsating DC output waveform contain ripple, which refer to the variation of fluctuation in the DC voltage. The magnitude of the ripple depend on factors such as the load, resistance, input frequency, and smoothing component used in the circuit. Next, move on to the output waveform, which is VDC T. At D2 and D4, the graph will go up and go down at the pi. Then it will go up again at D1 and D3 and we reach down at 2 pi, and again we'll go to D2 and D4 and go down at 3rd pi. The advantages is higher output voltage. Compared to other rectifier configuration, the full bridge rectifier provides a higher output voltage. This can be beneficial in applications that require a higher DC voltage level, and the disadvantage is higher cost. The full bridge rectifier circuit requires 4 diodes, which can increase the overall cost of the rectification system compared to half-wave rectifier that use only 2 diodes. Sorry for my internet connection. So right now I will explain about single phase to single phase cycle converter. A single phase to single phase cycle converter is a type of power electronic device used to convert the frequency of single phase alternating current. It allows the conversion of an input AC voltage at one frequency to an output VC and output AC voltage at a different frequency. while maintaining the single phase configuration. Next is a circuit configuration. I will present a diagram of single phase to single phase cycloconverter. As we can see, the cycloconverter starts by rectifying the single phase AC input voltage to obtain a unidirectional waveform. This rectification process is typically achieved using thyristor SCR connected in a bridge configuration. Next, I will talk about operation. The working principle of a single phase to single phase cycloconverter involve the conversion of single phase AC power to pulsating DC direct current through a rectification process. Here, a step-by-step explanation of the operation. Rectification. The cycloconverter starts by rectifying the single phase AC input voltage to obtain an unidirectional waveform. This rectification process is typically achieved using thyristor connected in a bridge configuration. Next is output voltage generation. When a thyristor is triggered, it conducts current, allowing the positive or negative half cycle of the input voltage to pass through. By controlling the timing and duration of thyristor conduction, the output waveform can be modified. We can see there is two types of waveform. First is VS and second is average voltage waveform. So we can see how much that is different when the two type of waveform is compared side by side. Lastly, the advantage of single phase to single phase cycloconverter is cost effective. Due to the simplicity and reduced component count, single phase to single phase cycloconverter can be cost effective compared to other frequency conversion solution. And now, the disadvantages. The disadvantages is limited power range. Cycloconverter has limitation in terms of power range that can handle effectively. They are often more suitable for lower power application due to the limitation of the thyristor used for switching. This concludes our discussion of single phase full bridge rectifier and single phase to single phase cycloconverter for today. Thank you, and I will now call the meeting to a close.